In today's lesson, we're going to be looking at reciprocal trig ratios. So this is going to be adding some more ratios to the main three that we know, the sine, cos, and tan. We're going to be looking at what's called the reciprocal trig ratios, which is going to be kind of the reciprocal versions of those three. So just a little bit of a review, right? Using the unit circle, which is a circle that has a radius of 1, we want to determine the three primary trig ratios for each of the following angles. Right? So remember sine, cos, and tan. Sine is y over r, cosine is x over r, tan is y over x. So this is what we looked at in the previous lesson. We're going to kind of use that to help us figure out the ratios for these three or these specific angles. So the first one, an angle of 0. So basically going from our, I'm going to use a different color that stands out, going from our origin to 1, 0 or 0 degrees. Right, so you have a 0 or 1, 0. So our x is 0 or 1 and our y is 0. In this case, sine theta is y over r. Well, if we think of r as the radius, right, in this case, because it's a unit circle, it is also going to be 1. So in this case, our y or our x and our r are 1 and our y is 0. So for sine theta, y over r or 0 over 1, it equals 0. For cosine, x over r, well, x is 1, so 1 over 1 equals 1. For tan, y over x or 0 over 1 leaves us with 0. For 90 degrees, actually let me keep this color coded. That was green. Oops. This was green as well. So for 90 degrees, so from origin to the top, right, again, it's a radius, so that r value is going to be 1. My x is 0, my y is 1. So for sine theta, right, y over r, or 1 over 1 equals 1. For cosine, x over r, x is 0, so 0 over 1 is 0. And then for tan, y over x, or 1 over 0 is undefined. Right? You get an error. You can't divide by 0. For 180 degrees, so going out to here, oops. Going out to here, x, y, radius, or r is still 1. So 180 for sine, sine of y, or sorry, y over r, or 0 over 1 equals 0. Cosine, x over r, so negative 1 over 1 equals negative 1. And for tan, tan of theta, or tan would be y over x, or 0 over negative 1, which is 0. And last but not least, 270 degrees, right? 270 degrees, we got 0 for x, negative 1 for y, and a radius of 1, again, because it's that unit circle. So theta, or for sine, sorry, y over r, negative 1 over 1 equals negative 1. For cosine, x over r, so 0 over 1 equals 0. And for tan, y over x, negative 1 over 0 gives me undefined. So again, just using some of those values, just kind of going over those y and r, those different ratios based off of points, or based off of coordinates for our trig ratios. So the three reciprocal trig ratios that we're going to be dealing with, they are the opposites of our primary trig ratios. So we know sine, which is opposite over hypotenuse, and if we flip it or make it 1 over sine, we would also flip the ratio, which would be, instead of opposite over hypotenuse, it's now hypotenuse over opposite. And when we do that, we get what is called the cosecant. So it's just another term for now the reciprocal or the flipped version. For cos. Right? Cos we know is adjacent over hypotenuse, A over H. And when we have the reciprocal, we have the secant, which is 1 over cos theta, or hypotenuse over adjacent. So it's opposite, right? Flipped. For tan theta, right, we know tan is opposite over adjacent. But when we flip it, or find the reciprocal, we have the cotangent, or 1 over tan theta, or the adjacent over the opposite. So these are all reciprocals, and these are because the two expressions, reciprocals are just two expressions that have a product of 1. So if I was to multiply sine theta by 1 over sine theta, I would have a product of 1. Right? So it's just another way to write some of these ratios or different ratios to kind of think about. So let's kind of do a review and an example all together. So let's review our special angles or special triangles. Right? And we want to then use our knowledge of the special triangles to complete the following chart. Right? So we're going to go through and fill out the chart. So for 0, right, sine 0, right, we have already done this. So I'm going to take this just from the previous one we did. Sine theta 0. So if I flip that and it becomes 1 over 0, that becomes undefined. Cosine theta was 1. So if I flip that for secant, it becomes 1 over 1 or 1. For tan theta, tan of 0 was 0. And again, I'm just taking this from this table here. And if I flip 0, or it becomes 1 over 0, that's the same thing as undefined. For 30 degrees, now I got to go to my special triangle. So 30 degrees, right, I'm looking at this half equilateral triangle. Sine is opposite over hypotenuse, so 1 over 2. 1 over 2. Oops, don't need to. 1 over 2. So cosecant is going to be the reciprocal of that, or 2 over 1, or just 2. For cosine of 30 degrees, adjacent over hypotenuse, or root 3. Sorry, not root 3. Root 3 over 2. And then for the secant, it's going to be the reciprocal, or 2 over root 3. Tan is going to be opposite over adjacent, or 1 over root 3. And the cotangent, or the reciprocal of tan, is root 3 over 1, or just root 3. For 45 degrees, we have, for sine, opposite over hypotenuse, 1 over root 2. So the cosecant is, we flip that, the reciprocal, or just root 2 over 1, same idea. Cosine of theta, adjacent over hypotenuse, so 1 over root 2 again. The secant, we flip it, comes root 2, or root 2 over 1. Tan, opposite over adjacent, is 1 over 1, and when we flip that, it becomes, for cotangent, it's also 1. For 60, sine of 60 is opposite over hypotenuse, or root 3 over 2. So the cosecant is 2 over root 3. Cosine is adjacent over hypotenuse, or 1 over 2. Cosecant then is 2 over 1, or 2. Tan is opposite over adjacent, root 3 over 1. So then the cotangent is 1 over root 3. And then for 90, I'm going to get back from my initial table up here. So 1, 0, and undefined. So we have 1, 0, undefined. So 1, if I flip 1, it becomes 1. 0, if I flip it, or 1 over 0 is undefined. And undefined, or 0 over 1, sorry, 1 over 0, and I flip it, 0 over 1, I get 0. So again, just kind of seeing what some of the exact values for our reciprocal ratios are. So now I want to determine the exact value for all 6 trig ratios for angle A. So we're going to do something similar, except now we have a specific specific values to deal with. So I'm going to start off with my initial one. So sine theta, cos theta, tan theta. Sine is opposite. So I'm going to use my reference angle, opposite, adjacent, hypotenuse. And I'm going to fill out my 3 primary trig ones first, and then I'm going to just do the reciprocal of it for the cosecant, secant, and cotangent. So sine is opposite over hypotenuse, or 12 over 13. Cosine is adjacent over hypotenuse, or 5 over 13. And tan is opposite over adjacent, or 12 over 5. So now if I want the other remaining trig ratios, I'm going to do the reciprocal. Cosecant will be 13 over 2. Sorry, cosecant of an angle is going to be 13 over 12. Secant of an angle is going to be 13 over 5. And the cotangent of an angle is going to be 5 over 12. So again, just the reciprocal, I'm just flipping my ratio. For the next one, example 3, each angle is in the first quadrant. We want to determine the measure of each angle. And that's important just because we know, just helpful to label because we have all positive values, so we know that it's going to end up being somewhere in this general area. Right, so cosecant of 8, or cosecant is equal to 8. Now if you look at your calculator, you might not find cosecant anywhere. Right? Maybe you're lucky, maybe you have those buttons somewhere, maybe not. Right? So, but because we do know that cosecant is the reciprocal of sine, I know that if I take 8 over 1 and I do the reciprocal, that's going to be sine theta of 1 over 8. And now I can use my sine ratio to determine what the angle is. Because I can do theta equals sine negative 1 of 1 over 8. I would get theta is equal to approximately 7.2. 7.2 degrees. Secant is the reciprocal of cosine. So cosine of theta would be 2 over 5. Theta equals, then cosine negative 1, right? We've looked at how to find angles before. So cosine of negative 1, 2 divided by 5, or inverse of cosine, 66.4 degrees. And finally, cotangent is the reciprocal of tan. So tan theta is going to be 16 over 5. Just flip that ratio. We get theta is equal to 72.6 degrees. So again, just understanding what the reciprocal is, so converting it back into sine, cos, or tan, and then using our knowledge on how to isolate for theta using the inverse to get our angle. So example 4, determine 2 angles between 0 and 360 that have a cosecant of negative 2. So again, this is going to be similar to what we've done before. So cosecant of an angle is equal to negative 2. So that means then that sine of an angle is equal to 1 over negative 2. I can go through then and figure out my angle. So theta is going to be sine negative 1, or the inverse of negative 1 over 2. and I get angle is equal to negative 30 degrees, which tells me it's the same thing as 330 degrees. Right? Because again, negative 30 means we go in this direction, 30 degrees, to my terminal angle, which is the same as going 330 degrees. So same thing. That 30 degrees is still going to be my reference angle. So if I know that I have a negative ratio, right, I also have to think about where else am I going to have a negative angle or a negative sine ratio. So the cast rule comes into play, CAST. Okay, I have to have an angle or an angle ending up in this quadrant. I'm going to use 30 as my reference angle again to the nearest x-axis, so 30. So then my actual angle is going to be from 0 to here, or 180 plus 30 equals 210 degrees. So therefore, we can say that sine 330 is equal to sine of 210, right, which is equal to negative 1 over 2. We found the two angles that are equivalent to this, or we could even say as well, if we wanted to, equal to cosecant of any of those angles. Right? So we could say the cosecant as well. Good. Right. So right, this is just kind of looking at the different or the reciprocal ratios. So three other ratios that are related to our three primary trig ones. Again, just different ways of kind of labeling it, different ways of kind of talking about it, just understanding what those terms or what these new ratios represent. And we can do kind of everything that we've done before, we can do similarly. We just have to convert back to our three primary trig ratios.